Hey there, in this video we're going to look at how we can compare values in Python and then how we can use something called an if statement to take different actions depending on the result of that comparison. So our simplest comparison is to check if two values are equal. Let's make a variable here. Make x equal to 1. And then I want to check to see whether or not x is equal to 1. Okay, I mean now, clearly it is because I just defined it, but suppose this was somewhere later in my program. I want to check is x1. I use a double equals for that comparison. Note the difference between these two lines. The first line says attach the name x to the value 1. The second line says check if the value x is 1. And the answer there is true. So true is a special kind in variable. We can even assign that to a variable. So we can say y equals true. That's a legal statement because true is a special kind of variable called a Boolean. If you call it the brother or the sister of true is false, so we can also assign that to variables. Okay, anyway, so I can check if x is equal to 1. I can check if x is equal to 1.0. Even though x was given an integer value, and I'm comparing it to a float, this will still work out and it will still say true because Python will promote x to a floating point value before it does the comparison. Now when we are comparing with floating point values, we have to be careful. Remember from the previous video when I said 0.1 plus 0.2 and we compare that to 0.3. Yeah, that says false because when we do the addition, 0.1 plus 0.2, we don't get exactly 0.3. We have some rounding error, and the rounding error between Python trying to calculate 0.3 in binary versus these two values, 0.1 and 0.2, which are both not quite equal when we do the rounding error, and then we round when we add them, we get slightly different things on either side of our equal sign. So you gotta be really careful when you're comparing floating point numbers. The better way to do this comparison is just to check if they're really close. And so we want to do that with a subtraction. So we'll take 0.1 plus 0.2, subtract 0.3, and we're not going to check if it's equal to 0. We'd have the same problem, but we're going to check if it's less than some tiny number. Depending on your context, maybe say a 1/1,000,000th is small enough. Now, doing a comparison like this, we have to be a little bit careful because we could end up with a negative result, and a negative result would always be less than 1 times 10 to the negative 9. So what we really want to do here is take an absolute value of the whole thing using a command called abs for absolute value. This is such a common thing that even though this is a math-like function, you don't have to import math to use it. It's just in regular Python because you have to use it so frequently. So we would do the absolute value of 0.1 plus 0.2 minus 0.3. It's going to be, I think it was around 10 to the minus 17, I think, which is smaller than 10 to the minus 9. So upon running that cell, we'd get the success we'd expect. All right, so we've seen equals. We've seen less than. There's greater than, of course. We also have greater than or equal to, less than or equal to. Not equal has an exclamation mark in front of it. So we could check, if x is not equal to 2, it was equal to 1, so that's going to be a true statement. There's another two comparison operators that come up, and their names are in and is. So in is used with lists, tuples, and dictionaries, any kind of collection of objects. So let's say I have a list that's equal to Jenny's phone number, 8675309. Okay, and I want to check if 3 is in that phone number. The answer there will be true because 3 is in the phone number. But if I check for 2, 2 is not in the phone number. The last comparison is, and that checks if two values are pointing to the same piece of memory in Python. So if I say, this is especially handy when we're dealing with lists. So let's say I make a list A that's equal to, let's say 1, 2, and I make a list B that is equal to 1, 2. Oops. 1, 2. These have the same value as each other, So I could say A equals B and I get true. But A is not B. They're not the same piece of memory. My memory in my computer has 2 copies of the value 1, 2. So if I say A is B, this tells me false. They're not the same memory. Whereas if I say C equals A, okay, I've said make C refer to the same thing that A does in memory. Then if I ask C is A, I'm going to get true. Make a quick picture of that. Okay, so what we ran there is we bound the name A, the memory that contained 1, 2, and then we created another name B and bound it to memory that we wanted to contain 1, 2. But we had to reserve even more memory in our computer to do that. And then we said, I want C to be equal to A. So that says take C and refer to whatever A refers to. And that makes A and C now share the same bit of memory over here. So C is A. That also means that if I change C, I'm going to change A, and vice versa. Whereas if I changed B, it has no effect on A or C because it's completely different memory. So we don't usually use is while writing a program. This is more for debugging or figuring out what's going on in our program. In does come up pretty frequently if we want to check that something is in a list of values. We can also use in with strings. So, if I want to know, do I have an A in my name? The answer is I do. It'll tell me true. There is an A in there. Okay, so that's individual comparisons. What if we wanted to do several comparisons at once? Like, let's say I wanted to check if x is positive. I do x greater than 0. And I want to check if x is a multiple of 2. To check if something's a multiple of 2, I could use the modulo operator. So if x is a multiple of 2, and I divided it by 2, I should have a remainder of 0. Okay, so I've got these 2 different comparisons, but I want to check both at the same time. The way I can do that is with and. So I type out the word and I can check if x is greater than 0 and x is divisible by 2. I think the last time we had x, it was equal to 1, so this should say false. But let's change that. Let's make x equal to 4 so that we know that this should be true to make sure it works, and sure enough it does. And we can have multiple statements separated by ands. There's another command called or, which will check if either of these is true. So if I made x equal to 1 again, the first part is true, but the second part isn't. But the overall statement, this or that, is true. So I'll get a true. I can check for the opposite of something by checking for not. So I could do not x greater than 0. Which would be the same thing as saying x less than 0. We're kind of making this needlessly complicated. I just wanted to show you what the different syntax is. Or x is divisible by 2. In that case, or a case like this, things are complicated enough that we really should use parentheses, not because the computer needs them, but because just me reading the computer needs them. So this makes it a little easier to read. Okay, so is not x greater than 0? That's false. Is x divisible by 2? That's false. So the result here is going to be false. You know what? Actually, I put the parenthesis in a bad place. Sorry. I should have put that parenthesis there. That's better. Okay, so that's how we can do our comparisons. Now, comparisons by themselves are not especially useful. But when we combine them with if statements, then we can have code that does different things in different cases. Like, let's say we want to calculate coefficients in a polynomial, and the even coefficients follow a different form than the odd coefficients. We could do what's called an if statement. If this coefficient is divisible by 2, then do this first thing. If my coefficient is not divisible by 2, then do the second thing. And the way we do that in Python is with if. So if comparison, then do whatever. So if x is, let's say if x is positive, then I want to do something. So if x is positive, let's do something real simple, like just print out a plus. All right, well, I think x is equal to 1 from the previous cell, so this should print out a plus for us. let's change the value of x. Let's make x equal to -1 so it's not positive anymore. And now we see the if statement doesn't trigger the following line. Let's say I want to do something though in the case where x is not greater than 0. In that case, I can follow up this if statement with an else. So this means in any other case, then I want to print a minus sign. Sorry, too many parentheses there. Notice how I write this. I have a colon after each of these, and I've indented here by 4 spaces. I just hit the tab button. That automatically added 4 spaces. So in Python, the way it knows if it's inside a block is with this white space indentation. This is different than a language like C or Java. In a language like C or Java, you would use curly braces, like so. That is not meaningful in Python. You have to use the white space. Now, I know people have very strong opinions about this. It kind of depends on what language you saw first. So like if you started and you've worked a lot with a language like C or Java, you say, oh, this is terrible. Why are you forcing me to have this white space? You started with Python, you say, why do we have to write all these curly braces? I'm going to indent my code anyway when I type it so I can read it. Well, there's nothing we can do about it. That's just how this language works. Okay, so it's going to be indented. And you can have multiple statements in your if statement. So let's just put in a do nothing statement here, like 1 + 2, 3 + 4. All of this stuff here is going to be executed by the computer if x is greater than 0. And if x is not greater than 0, this next part will execute. So here we'll see it prints a minus. Now you might notice that this particular code doesn't do something sensible if x is equal to 0. If x is equal to 0, it's not greater than 0. And so it prints a minus sign. Well, that's not minus. That's a special case, right? So what we might want to do in that case is have another piece to this called else if. We're going to put that in the middle here. So instead of doing else, we're going to do else if, elif in Python. Elif x is less than 0, then print minus. And then the last case would be whatever's left over, meaning x is 0. Then we could print a 0. All right, in that case now, it's going to check, is x greater than 0? Nope. Is x less than 0? Nope. Well, then it must print 0. Check if it's positive. Does it print positive? Yep. What if x is negative? Then it prints negative. Okay, so now we have more sensible code. Now, of course, if someone does something like types in the string 1, well, okay, 1 is not greater than 0. It's going to be kind of mad when I try to do that comparison. So we could make even more complicated code that checks the type of x. Usually, though, you shouldn't have to write code that checks for the type of your variable. If you find yourself doing that or tempted to do that, you need to rethink about how you structured your program. Even though you can check the type of a variable, you shouldn't have to. Your program should be doing common sense things. Even if Python doesn't force you to do common sense things, you should still do common sense things in your code. Okay, so that is how we do comparisons in Python and how we can use if statements to take different actions depending on the result of the comparison. Coming up, we're going to look at how we can repeat some operation over and over again with a loop.